HAWC, a unique gamma-ray observatory. There is a universe that we cannot see with the naked eye. This changing and violent universe contains amazing phenomena as the death of stars, accreting black holes, active galactic nuclei flares, and the collisions of neutron stars, to mention some examples. This universe is observable in gamma rays, light that is millions of times more energetic than visible light. A new observatory is born in Mexico. The national park Pico de Orizaba is situated between the states of Puebla and Veracruz and comprises the Citlaltépetl volcano, the highest natural elevation in Mexico, and the volcano Sierra Negra that will host HAWC, one of the most important astrophysical projects developed in Mexico. The excellent meteorological conditions of this site and its high altitude make it an ideal location to observe the universe. In 2007, scientists of UNAM, INAOE, the University of Maryland, and Los Alamos National Laboratory, with other 19 institutions from Mexico and United States, joined their vision and efforts to build this unique gamma-ray detector. HAWC, the High-Altitude Water Cherenkov Observatory. Other sites at altitudes higher than 4,000 meters above sea level were considered as hosts to HAWC: Chacaltaya in Bolivia and Tibet in China. However, the volcano Sierra Negra was selected thanks to the solid and extensive experience of the Mexican groups in other international projects, such as the Gamma Ray Observatory Milagro in Los Alamos, United States, the Large Hadron Collider, LHC, at CERN, Switzerland, and the Pierre Oyer Observatory in Argentina. Moreover, the volcano Sierra Negra counts with the needed infrastructure, which includes access road, electricity, and optical fiber that has been developed for the Large Millimeter Telescope. The Large Millimeter Telescope and HAWC will transform the volcano Sierra Negra into an advanced frontier astrophysical laboratory that will stimulate the already consolidated leadership of important Mexican institutions of education and research. The gamma rays from the most violent events of the universe cannot reach the ground level since they interact high up in the atmosphere with gas molecules, starting a particle cascade or shower that loses energy as it penetrates the atmosphere. These particles enter large water tanks where they can travel faster than the light in water, and similar to a supersonic airplane, they emit a shock wave, leaving light behind them. This so-called Cherenkov light lets us know that a particle has entered a tank. To reconstruct the original gamma-ray direction and energy, it is necessary to detect as many particles as possible. Therefore, an observatory of the highest energies requires a large area detector at an altitude higher than 4,000 meters above sea level. HAWC will consist of 300 large water tanks of more than 24 feet in diameter and 16 feet in height each. Scientists studying diverse subjects such as solar flares, blazars, black holes, and dark matter find the HAWC Observatory an ideal instrument with which to study these topics, gaining new knowledge about what is taking place in these violent events. HAWC will help answer some open questions, but also will open new ones about the origin and evolution of the universe. To crystallize the dream of observing the most energetic and violent universe, it has been necessary to combine the work and support of American and Mexican institutions led by the University of Maryland, Los Alamos National Laboratory, the Astronomy and Physics Institutes of UNAM, and INAOE. In 2008, partial funding was received from the National Science Foundation, the University of Maryland, CONACYT, UNAM, INAOE, and the University of Chiapas for feasibility studies including the construction and logistic details at the site. From November 2008, to February 2009, a HAWC prototype of 3 Cherenkov detectors was constructed. Each detector consisted of an 8,000-gallon water tank with several extremely sensitive light detectors. The prototype is at 4,530 meters above sea level, 1 kilometer from the final HAWC site, and very close to the large millimeter telescope to take advantage of the existing infrastructure. In parallel, the permit for the construction of the road to the HAWC site was obtained. In March 2009, the prototype detected its first cosmic rays, making a very preliminary sky map. The progress achieved so far demonstrated the technology proposed for the HAWC Observatory and gave valuable experience to the Mexican-American collaboration. In March of 2010, the construction of the observatory has started with an array at the final site built in 4 sequential stages of 7, 30, 100, and 300 Cherenkov detectors. Already with the first 30 detectors, HAWC will become one of the most advanced, large-aperture, continuously operated gamma-ray observatories in the world with large scientific impact.